अच्छा था और फिर स्कार्फ और ब्रांड
का किलो 400 तो बना नहीं मैं दिया ही नहीं तू दिया मैंने निशान में देगा जो हमारा
no that's
नहीं है ये
तेरे बाजू वाले से ले आगे वाले से पीछे वाले से ले कहां से तो लेना यहां पे क्यों पागल और तो देखेगा और
पार्ट सून तक के और डिफरेंट
आगे मदद तेरा भाई
ऐसा बस पहुंच के तीन मिला
7 पीस
मेरे हाँ सेक्टर 8 5 मिनट में आएगा
अरे प्लीज
कैसे जाता है
गूगल
ये तो दोनों भी मैक्स एमबीपीएस में आए थे
हाँ सब लोग गए थे मुझे लगता है कि सवाल
तो इसमें एक साथ के
तेरी सुविधा उसके साथ हाँ
23 लोग को देख रहे हैं
कितने पार्टी का क्लास था अपनी खाओ यार ये एक मिनट स्टॉप कर दीजिए हाँ मैं तो सीरीज तो एक शक्ल वाला करता है ये शक्ल है अब ये अरे पता है देखो ये देख पता है तो लेवल
क्या क्या
नहीं
कौन है उसका
नहीं सिर्फ से अरे अनन्या का है
अनन्या कौन
अनन्या श्रीवास्तव अनन्या श्रीवास्तव
अबे बाकी के फोटोज
अनन्या श्रीवास्तव अरे उसको
मेरा क्या
अरे मिल रहा था मेरा टिकट पास
देखो दर्श पे
अनन्या श्रीवास्तव
ओ
अरे मेरे क्लास में है काली सी
अरे ये लो क्या बोले
कौन
अरे पास बोला
अनन्या श्रीवास्तव करके
ये
काली सी ये तो हाउस कैप्टन है
अब की
है
बस
Sit down, please. Where did we stop in the last class? Middle. Where did we start?
Relation between E and T.
D, okay, small g and capital. We have derived the equation.
Yeah.
Yes, sir.
It's what you do.
Yeah, so I'm just writing.
The page number.
46. Did we discuss motion under free fall? We discussed it, right?
Most.
No.
Universal law of gravity the Udays.
And relation between capital G and small.
Yes.
Free falls the start.
The difference नहीं किया.
किया है
Which difference?
difference.
लिखा है
Which difference?
Capital G and small.
लिखा है लिखा है.
हाँ.
we have written it sir.
During the definition itself, you have to know now. What is small g? Acceleration due to gravity. What is capital G? Universal gravitational force. Universal gravitational force. Okay. So, what is the importance of law of gravitation? What is the importance of law of gravitation? It explains about the motion of planets around sun, motion of moon around earth. Okay. So you can actually explain all that due to universal law of gravitation. There exists force of attraction between planets and sun. How much is that force? You can calculate using universal law of gravitation. Okay. Second, we are bound to Earth's surface because of. So universal law of gravitation explains that as well. Correct? Why every object is bound to Earth? Because of gravitational force. Okay. That force you can calculate using universal law of gravity. It also explains the formation of tides. It also explains the formation of
Right.
tides. So what are tides?
Right.
Tides are caused due to force of attraction between water and moon. For different phases of moon, right? You have tides.
How does it help in tides? How?
So moon tries to attract Earth, but Earth is too heavy to be influenced by moon. But water is fluid, so it just tries to raise the level of water.
Sir, what
That's all.
does it have gravity?
Who doesn't have gravity? Who told you? Does moon have mass?
This
Sir, what if
So what is gravity because of? What is the reason for gravity? Mass.
What if we don't have any moon?
Then no force. What if we don't have any moon? No force.
Water won't be settled then.
It's,
No moon.
no
no, it won't be. No, wave. Okay, wave is different. Wave is due to the motion of air. Okay. So when the air flows, so it comes in contact of the free surface of water and it influences it. So then it disturbs the still water. And that's how the waves are. You can generate waves yourself. The bucket or a tub of water, drop something. See, water level disturbed. Okay. So let's not digress. So I just explained the importance of law of gravitation. Just read through it. Everybody has volume. So is there any point that you don't understand with this? Also, the motion of a freely falling body can be explained by this law. Right? Understood? Okay. Let's now discuss free fall. What is free fall?
Before is when an object falls from a certain height.
Oh.
Towards
Only under the influence of Earth's gravity. Like if there is a rocket, okay, instead of going up, if it is coming down, so it's not free fall. Okay, it is just not a body dropping under Earth's gravity. There is jet propulsion taking place. Okay, so that's not a free fall motion. Free fall motion is
During the war in
during free fall, the object falls towards earth. Only under the influence of Earth's gravity. So when I say gravity, what does it mean? Force. Earth's gravitational force. Okay. So during free fall, is it a uniform motion?
yes, 9.8 meters per second.
But it is keep increasing to its fallen down.
What did I ask you? Is it a uniform motion?
Yes,
What is the property of uniform motion? What is the characteristic of uniform motion?
the motion increases in an uniform
Way is a uniform motion.
Oh,
That's what I'm asking, what is uniform?
Object covers equal distance and equal in the
So in uniform motion, what is constant?
time.
Speed is constant. Is speed constant?
no. It's
Initially, its speed is 0. Then it is increasing each second. By how much?
9.8.
9.8.
So how it is uniform motion?
Constant.
So what is uniform in this? Acceleration. So it is uniformly accelerated motion. Understood? Uniform motion is different. Uniformly accelerated motion is different. So what is happening in this case? During free fall, what is constant? The acceleration. So during free fall, the object under free fall accelerated. So during free fall, the object develops an acceleration. Okay, given as g equal to 9.8 meter per second. Thus, free fall motion is an uniformly accelerated motion. So free fall motion is uniformly accelerated motion. Clear? This is it. Now you can have both free fall motion, upward and downward. Both can be
We
considered.
call it upward motion.
If I throw this object upward, so this motion is also under gravity only. The moment object is projected up, this motion is under what? Under gravity. Okay. So this is motion under free fall only. Which force is acting the moment I project? Only gravity. Okay. So under free fall, we discuss both the motion. So one is motion under free fall. First is downward motion. So when a body is dropped from a certain height, let's say this is ground. When a body is dropped from certain height, then it will undergo downward motion. So what is the initial speed of the body? 0. But when it hits the ground, it will have some speed.
Retardation is two.
What are you saying? Its velocity is continuously increasing, so how it will be retarded?
Touch on the retard.
Touch nahi. Just before it hits the ground, it will hit with maximum velocity. It is not retarded. After touching the ground, where is the free fall motion? Okay. So, and how much distance it has covered? Let us say it was dropped from height h. Okay. So during downward motion, this is accelerated motion. So this is G is positive plus 9.8 meter per second.
Sir, so 9.8 meters second into how much time?
Meter per second squared.
Meter per plus second square into how much time it took will be the velocity of the object which is hit the ground.
Yes. E is equal to U plus GT. We will write all those equations. First, you understand the characteristics of motion under free fall. Only two types of motion possible. We have only straight line motion. Okay. So either it is dropping down or it is going up. Only two motion. You don't have motion in a plane like projectile. ऐसा नहीं है. मतलब ball को फेंक रहे हैं तो it is two-dimensional motion. It is a motion in a plane, not that motion. For you, either it is falling down or it is going up. Only these two motions.
Yeah, so bungee jumping, G jump too.
Yes. That is a
The
free fall.
same case.
Yes. Now, or a bouncing ball. You drop a ball. That will be this motion. Now, upward motion. So now you are throwing the ball upwards. What will happen? Let's say you have thrown it in such a way that it covers the same height.
H.
So you projected the ball with some velocity.
Initial would be 0.
Initial will be 0. Then how will it start moving? If the initial velocity is 0, it will remain at rest only. So you have to give it some initial velocity for upward motion. So for upward motion, initial velocity will not be 0. Will not be equal to 0. And here V is not equal to 0. There will be some
But final velocity would be equal to 0. Right?
Listen, that's not final velocity. Final velocity under free fall. Free fall. You have to understand this motion. When it touches the ground, there is no more free fall motion.
Yes.
So
but in
last-
that case.
First, understand this. When I say V, it is which velocity? Just before it touches the ground. Last velocity achieved under free fall. It is that velocity. Clear? As long as G is acting. Once it touches the ground, then because of G, there is no change in velocity. Okay? Understood? Now here you are throwing with some initial velocity. So initial velocity cannot be zero. But once it reaches the maximum height, what is happening? What is the status now? G is still acting downward, but now it is against the motion. So D is no more acceleration, it is retardation. Okay, in this case, for downward motion, G is positive. G is positive for downward motion. For upward motion, G is negative. That is why at the top, what will be velocity? like braking situation. So when you brake, continuously apply the brake, body has to stop from it. So that is due to retardation. Here also, the upward motion is retardation. So under free fall, these two categories of questions you have to answer. Now, I mix both. I throw a ball, then I catch it. So it covers both the motion.
Yes.
In this case, the time taken to reach the maximum height and the time taken to fall back on ground is same. Understood? Let's say it takes time t to reach the maximum height. So while falling down also, it will take time t. Okay?
So,
So,
but it will depend on the force that how much force it applied.
so force will decide the height covered. So whatever height it has reached, while coming down, it is traveling the same height. The distance is same. Vertical distance in both the situation is same. And the acceleration also is same. So the time taken also will be same.
Sir, but if we throw the ball harder, it will cover more distance in less time.
Okay. Then
But when it will come down, it will be at a constant. It will
so when you throw it harder, what you are providing?
more force.
You are providing more initial velocity. That's all. So when it comes down, this velocity will be equal to this velocity. You understand? Because what has reduced the velocity to zero? Retardation. But now it is starting the motion with zero velocity. Now this retardation becomes acceleration by same amount. So it hits the ground with the same initial velocity. It is a symmetric motion. ठीक है? समझ आ गया? So this is how it will help you in solving numericals. You split the full motion into two parts, upward and downward motion. And you have to keep in mind, it will be equal time giving. Note. When a body is going upwards, the time taken to reach maximum height and the time to fall back on ground is same. Keep this in mind while solving numericals. So what two things you have to keep in mind? The sign of G and this thing. And what is the second thing to be noted? The final velocity is same as initial velocity on completion of the journey. Okay. Okay. So more we will learn when we solve the numericals. For now, just keep these things in mind. Okay, just make a note. Second point is the final velocity the object will hit the ground will be same as the initial velocity of projection. ठीक है, जो वेलोसिटी से इट वाज प्रोजेक्टेड अप, when it falls back under free fall, okay, the velocities will be same. So velocities and time and the height, all of these are going to be same. It's a symmetric motion, right? भाई सेम ही बॉडी तो ऊपर जाके नीचे आ रहा है, तो एच सेम हो गया, टाइम सेम हो गया, और जो इनिशियल वेलोसिटी था वो भी सेम हो गया, फाइनल वेलोसिटी, ठीक है, जी भी सेम लग रहा है, एक में एक्सेलरेशन का काम कर रहा है, दूसरे में रिटार्डेशन, ठीक है, तो एवरीथिंग इज, so now we'll write the equations of motion. Under free fall. Or downward motion. So what is the equation of motion? We have V is equal to U plus dt. Okay. Then you have S is equal to ut plus half at square. Then V square minus U square is equal to 2as. This is the equation of motion we are familiar with. तो इसमें फ्री फॉल में कैसे कन्वर्ट करेंगे? For downward motion, substitute K G and S is equal to H. The acceleration becomes acceleration due to gravity, and displacement becomes height because it is a vertical motion. तो इससे हमको क्या मिल जाएगा? E is equal to U plus gt. तो डाउनवर्ड मोशन में G पॉजिटिव है ना? G is positive. S is equal to ut plus half dt square. V square minus U square is equal to 2ghi. You can hi. ठीक है, इसमें एक चीज तुम और कर सकते हो, डाउनवर्ड मोशन में you can put u as 0. You can put u as 0. Initial velocity क्या है डाउनवर्ड मोशन में? 0. ठीक है, तो this can be like this will be half gt square. This is equal to, यहाँ पे क्या कर सकते हो, और v square is equal to 0. ठीक है, यहाँ पे taking u equal to 0. So ये सारे सब्स्टिट्यूशन करोगे तो तुमको क्या मिल जाएगा इक्वेशन? V is equal to gt, h is equal to half gt square, and v square is equal to 2gh. ठीक है ना? वैसे ही तुमको अलग अलग याद करने की जरूरत है. अपवर्ड मोशन में क्या होगा अभी? अपवर्ड मोशन में v 0, ठीक है, तो और g क्या हो जाएगा? माइनस जी. तो अपवर्ड मोशन के लिए इक्वेशन में खाली g का साइन चेंज होगा और u की वजह क्या 0 होगा? v. ठीक है, तो फॉर अपवर्ड लिख लो. सिमिलरली फॉर अपवर्ड मोशन V is equal to U minus GT. Actually इसमें confusion क्या होता है? You don't have to substitute G as minus 9.8. अगर तुमने माइनस यहाँ पे ऑलरेडी लगा दिया तो गलत हो जाएगा. समझ में आया? G you have to substitute minus 9.8. But here we are writing minus G is already. So you have to substitute G सिर्फ 9.8 ही रखना है.
Negative.
हाँ फिर से नेगेटिव कैसे करोगे? यहाँ पे हमने माइनस जी कर दिया इसलिए जी की वैल्यू हमेशा 9.8 लेके चलो. ठीक है? So you should not memorize these equation. You should only memorize this. और A को G और S को H करो. तो जहाँ पे जो G एप्लीकेबल है वैसा साइन देंगे. इसमें नहीं तो तुम्हारा मिस्टेक हो जाए. ये जो इक्वेशन दिया हो बात समझ में आई? Value of G is only 9.8. It will become plus for downward motion and minus for upward motion.
सर वो अपवर्ड पोर्शन में V सी रहता.
हाँ तो ठीक है ना तो उसको डाल दो ना बीच में. ठीक है. सो ठीक है. सो अगर तुम फिर से सिंप्लीफाई करोगे तो क्या हो जाएगा? Taking B equal to 0 at maximum height. देखो क्वेश्चंस में तुमको मैक्सिमम हाइट वाला ही होगा. इन बिटवीन तो देगा नहीं तो कॉम्प्लिकेट होगा. ठीक है. सो मोस्टली तुम्हें ऐसा सिनेरियो देगा जहाँ पे सम वैल्यूज विल नॉट बी गिवन इन द क्वेश्चन बट यू हैव टू इन्फर फ्रॉम द सिचुएशन. मैक्सिमम हाइट बोलते हो तो यू हैव टू अंडरस्टैंड कि अगर नीचे से ऊपर देख रहे हैं तो क्या होगा? V0 height will be maximum. Okay. So when we solve numerical it will become clear. Okay. All right. With this, we come to the last part of last topic, which is difference between mass and weight.
मैंने वो पिछले वाले चैप्टर में पूछा था.
पिछले वाले चैप्टर में तुमने पूछा था तो मैंने यही बोला था कि वेट टिल द नेक्स्ट चैप्टर. ठीक है. So now we'll discuss. So what is the difference between mass and weight? I think I will clear this. Everybody has written it. Can I erase this first one? Online students, Washworth and Swastika. You can just show by and thumbs up. Affirmation. Are you with me? Vivaswat and Swastika?
Yes, sir.
Okay, so when I have to erase, you have to just give your confirmation. Can I erase the second column as well?
Yes, sir.
Yes, sir.
Yes. Okay, now we do the last topic, which is difference between mass and weight. So how many of you thought that mass and weight are the same thing? Or is mass and weight same thing? No. What is the difference?
Mass is kilo.
Mass is kilogram, mass is measured in kilogram, and weight is measured in Newton. So obviously there are different quantities. So mass is the measure of matter content. In a body. Right? Mass is the measure of matter content in a body. Whereas weight is the Earth's force of attraction, Earth's gravitational force of attraction. So if you are holding 1 kg, right? Then what is the weight of 1 kg? 9.8 Newton. M into G. Force is mass into acceleration due to gravity. Newton's second law.
So 980.
Not CGS. 9.8 मीटर पर सेकंड स्क्वायर अभी तो पढ़ा है 980 कैसे होगा 1 kg होगा
So 1 kg में 1000
न्यूटन में कितना हुआ 1 into 9.8 न्यूटन okay so what is unit kg what is the SI unit here
Newton.
Newton. Okay, so these are different physical quantities. So when you measure your weight, what do you say? What is your weight?
Actual weight.
Approximate.
That's good.
Huh?
I didn't know.
What is your weight? Have you measured yourself recently? What is your weight?
72.
72?
32.
52.
52?
20.
What?
It's
Kg. You just said your weight is 2 kg. What is the unit of weight? Newton.
Yeah.
So this is a very common, mistake that we do.
Weight was 52.
हमको अपना बोलना चाहिए कि my mass is 52.2 kg, not weight. लेकिन सोसाइटी में वही चल रहा है. Means this is a what do you call misrepresentation. We say mass as weight. Okay, but you should now understand what is the difference. When we measure our mass, it's mass in kg, not weight in kg.
the weight is the force acting upon us due to gravity.
It is the force acting on the mass. So how do you calculate the force on a mass?
The
Mass times the acceleration due to gravity by Newton's second. Or by Newton's universal law of gravitation, it is also the same thing. F is equal to what? Mass times gravity.
mg.
Or F is equal to यही तो G है. What is G? Yes, universal law by universal law. यही तो G है हमारा small g. So this is our weight. समझ आया?
Big G तो ये big G
Big G सिर्फ big G नहीं है. Big G, big M, mass of Earth divided by radius of Earth square भी है. यही तुम्हारा small g.
okay.
यही तो तुम्हारा small g है. ठीक है? तो फर्क समझ में आ गया? What is weight? Mass times g. जबकि mass क्या है? Mass is only m. Mass is only m. That is mass. Okay. Third. C over here. So therefore, mass is a scalar quantity. It has only value, it has no direction. Whereas force has direction as well as value. Weight is vector quantity. Okay, weight is vector quantity. So it has both magnitude and direction. What is the direction of weight? Downwards. Okay, direction of weight is always downward towards the center of earth. Fourth, it is constant. Mass of the body is constant anywhere in the universe. Okay, so mass of body remains constant.
Sir,
Everywhere. Anywhere. Yes,
sir, our mass continuously increases or decreases, right?
yes.
Then how is this sentence applicable? Our mass increases or decreases now?
In a given time. Like if it is you are a living body. So that's why you're growing all the time. But what about this bottle? Let's see. Your mass will not forever increase. Why otherwise doctor notes your mass?
Sir,
Once you are a grown up adult, will it increase the way it is increasing now? No. Provided you're eating right and following all the right living practices. Generally, these things don't change on a daily basis. Not so soon. It will change over a period of time. Not at the same time. Okay. So the mass of a body remains constant everywhere in the universe when I say this at that point in time. Okay. What about weight?
It differs
Why?
on the gravitational pull of a mass or body.
Weight of the body may vary from place to place. Due to change in value of D at respective place. The small g is not same everywhere. We have seen in case of Earth, it is maximum at
9.88.
pole. Value of g is maximum at pole and minimum at equator. Equator. So if you move from pole to equator, then it gradually decreases. So g is not same everywhere.
Because equator is away from pole compared to the pole.
So that is about place on Earth. The same object whose mass is 5 kg. On moon also it will remain 5 kg only. But the yes, mass remains same. No? Weight changes there. Weight becomes 1/6. 1/6. The acceleration due to gravity on moon is 1.6 meter per second, which is 1/6 of 9.8 meter per second. So its value of Earth. Okay. So this is what it is. So how do you measure? It is measured by using a beam balance.
Sir, what is the difference between magnetic force and earth gravitation?
The cause is different. Earth's gravitational force is caused by mass. Magnetic force is caused by charged particle in motion, that is electric current.
But earth also has a magnetic field.
Yes. Earth has magnetic field.
So
It has gravitational field as well as magnetic field. Both. It has both. So it is measured using a beam balance. How do you measure weight? Spring balance. It is measured by a spring balance. Okay. So mass of a given body can never be zero. Mass of a given body is never zero. Right? Any body which has matter will have some mass. Right? But can its weight be zero?
Yes.
Where? Wherever G is
then not in space.
Wherever G is zero.
in space. You can create vacuum in lab also. So what lab is? Vacuum. Vacuum inside lab, there will be weight. Okay. So नहीं होगा. लैब में नहीं होगा. But space में हो जाएगा. Weight can be zero. Wherever G is equal to 0. Down to space or at G is 0 at center of Earth. Okay. So everybody understand what is beam balance or physical balance? It is also called as physical balance. You're familiar with what is beam balance? Taraju बोलते हैं ना taraju. Everybody understands taraju. See, today we have all electronic beam balance. So physically the numbers are printed, right? Like if you go to the gold shop, so electronic or any grocery vendor also these days has electronic beam balance. So where do you get taraju? Huh? Randiwala has, but those are big ones.
Flash.
Even they have now digital. Like on airports. Airports, what do you have? You have a platform. When you keep digitally, it is displayed. So even Randiwalas have now the digitally displayed.
Large ones.
Some of them still have. But it is getting phased out. Very soon you'll have to visit a museum to
Vendors.
vegetable and fruit. Street vendors you'll have. Yes. Rural areas you may find still. Okay. But now it is getting replaced. And soon we'll have only digital. So are we good till here? Okay. So now we'll do some numericals. So let us do the solved examples first. We haven't done any solved examples, right? Have we? Let's discuss. So come on page number 42, everybody. page 42. Better. So how to solve a question? Read the question and write down the given data. So what is given? Given. Mass of the ball is 10 gram. Initially moving with velocity 50 meter per second. When applying a constant force, the ball for 2 seconds. T given is 2 seconds. It acquires a velocity, the final velocity is 70 meter per second. Calculate. So you have to calculate 5 things. So let's calculate one by one. So first you have to calculate what? The initial momentum of the ball. So what is the initial momentum? mu. Right? Initial momentum will be mass into initial momentum. Pi means initial momentum. T is the symbol for momentum. So it is given in grams. So I have to convert it into kg. So how much it will be? 10 divided by 1000.
0.01.
So this is equal to 0.01 into U is 50. How much is this? 0.5. Mass unit is kg meter per second. So this is the unit of momentum, kg meter per second. What is the unit of momentum? Unit of mass times unit of velocity, kg meter per second. Then second, now calculate the final momentum. Final momentum is what? mv. So how much is this? What is v now? 70. So this will be 0.7 kg meter. Clear? So rate of change of momentum. Third. So what is rate of change of momentum? Delta P by delta T. P final minus P initial divided by T minus 0. Correct? So how much is this? 0.7 minus 0.5 divided by what was T? So it changed in 2 seconds. So 0.2 divided by 2. 0.1. What is rate of change of momentum?
kg.
Newton. Rate of change of momentum is force. Okay. So this will be kg meter per second. What is the unit here? Kg meter per second. And this will be second. So this becomes 0.1 kg meter per second square, which is nothing but Newton. Kg meter per second square is Newton. Correct? This is how we have defined the unit of force. What is the acceleration of the ball? What is A is equal to V minus U by T? V was 70 minus 50 divided by 2. It will be 10 meter per second square. Fifth. Force. What is force? Mass into acceleration. So what is mass? 0.01. Acceleration is 10. This is giving us, we had already calculated. So the third and fifth is same answer. Third and fifth is same. Rate of change of momentum is nothing but force. So this is a very good question. It has given you the entire chapter summary. पूरा momentum, linear, final, change, सब कुछ cover हो गया इसके. ठीक है? So that is why you must do solved examples thoroughly. Okay. Anybody has any doubt in steps how we have done? Let's move on to example 2. Example 2 is on page 43. Okay, in the mass, before we go to example 2, while discussing mass and weight, we said mass is constant. Right? Now, which mass is constant? The rest mass. Okay? For stationary body. So whenever we are comparing the mass or treating the mass as constant, it is constant only for stationary body. But you know what? When the object begins to move at very high speeds, then its mass may increase. Okay, that is called relativistic mass. So,
Sir, what can that do? What can that speed do?
speed of light, close to speed of light, very high speed. So, stationary mass or rest mass, where M0 is called
Rest.
rest mass. Unnecessarily, they have given you this. This is an advanced topic to be studied in higher standards. Okay. So the change in relativistic mass is given as m is equal to its rest mass divided by 1 minus v square by c square. Okay. So v is the velocity with which the body of mass m is moving. So as v approaches c, right? अगर v c के बराबर हो गया तो ये क्या डिनोमिनेटर क्या हो जाएगा? C is the speed of light. So v is speed of body. And c is speed of light. First chapter में पढ़ा है ना तुमने? What is speed of light? C is equal to 3 into 10 raised to 8 meter per second. है ना?
Yes.
So as v approaches c, so v square by c square will approach 1. 1 minus 1 becomes 0. And mass becomes infinite. Denominator, the moment, see, whatever speed is there, right? Initially, if the body is at rest v will be 0. So it will be square root 1. So at rest, m is equal to rest mass. But when v increases, right? So when v increases appreciably, then the denominator becomes less than 1. Then the mass increases. So this is more true in case of bodies moving at very high speed, like electrons. So in atom, the electron mass will be relativistic mass because they travel at very high speed, almost near speed of light, like 2 into 10 raised to 8 मीटर पर सेकंड and second. ठीक है, तो वहां पे ज्यादा कंसीडर हो. अभी तुमको मैकेनिक्स में रिलेटिविस्टिक मास का कोई जरूरत नहीं, यू कैन इग्नोर इट. ओके, बट कीप दिस इन माइंड, यू नेवर नो, कहीं बुक में दिया है तो क्वेश्चन आ गया, बट नो क्वेश्चन इज एक्सपेक्टेड ऑफ.
Does it given in study?
It is there in theory. Is it in brothers? Do you have this formula in brother? Just check. I don't think it will be there. Selena, so many things extra is also there. But it is good to read. It clears the concepts very well.
There is looking out similar to okay.
हाँ, सेलिना से मोटा होने से कुछ नहीं होता. आदमी मोटा है लेकिन स्ट्रॉन्ग है, ये कोई गारंटी नहीं है. एक पंच फ्लैट. Okay, we'll continue in the next class.